Good evening and welcome. Tonight I'm going to be reading to you from this book called Discovering Mars. And this book is part of my Viewer's Choice Extravaganza. I like calling it that. Where at the end of the year, all of my viewers get to pick the topics that I read about. And this topic was pretty much chosen by Jarrett, who I think wanted a full-on history and geography video of Mars like I do about places around the world. That would be like a 10-minute video, but I think this book really covers history and geography better than I could ever summarize, to be honest. It's a great book. Also, William Trostel requested I do more about astronomy. A couple of you guys miss my astronomy videos I did way long ago, which got barely any views, but the people who viewed it loved it. So I stopped that series, and I'm always willing to talk more about astronomy. I love space. I love planets. I consider planetary stuff part of geography because our Earth that we study and love is part of the solar system, and so is Mars. So, without further ado, let's get into this huge book. It's so long. Hopefully I've got it all in frame. I can't really see my viewfinder. I gotta crane my neck up. It's up very high to see it, so hopefully it's all in view. I'll do my best. Chapter 1, Our Solar System. Our solar system has 8 objects that are officially classified as planets. These planets are typically ordered by how far away they are from the Sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Mars is the 4th planet from the Sun, with Earth as its closest neighboring planet. And then here's all of the planets all lined up, including Pluto over here, which just tickles me because we didn't see any photographs of Pluto until just a few years ago. So it's cool to see it included in books like that, even though Pluto's a dwarf planet, not a full-on planet. But that's okay. We're all friends here, aren't we? What is a planet? According to the International Astronomical Union, in order for an object in space to be considered a planet, it must orbit a sun, but it cannot be the moon of another space object. A planet must also be round and large enough to move objects, such as asteroids and comets, out of its way to continue its orbit. The types of planets. There are 3 different types of planets in our solar system: terrestrial, gas giant, and ice giant. The first 4 planets closest to the Sun, Mercury, Venus, Earth, and Mars, are terrestrial planets. This type of planet has a rocky, solid surface. The next 2 planets, Jupiter and Saturn, are gas giants. The opposite of terrestrial planets, gas giants are mostly made up of gas. The last 2 planets, Uranus and Neptune, are ice giants because they are primarily made up of ice. And fun fact, Pluto was considered a planet until 2006, when it was reclassified as a dwarf planet. I don't want to hear any rah, Pluto's a planet, Pluto's a planet. It's one of those, so we have hundreds of dwarf planets, and the what's it called, just outside our solar system, but within it, by the Oort cloud, there's hundreds. So either we have 8 planets or we have hundreds of planets, and the school children have to memorize these hundreds of planets. So Pluto's one of the many dwarf planets. It's just Pluto was discovered before all the other dwarf planets were, so they thought it was a planet. It's not. It has a bunch of friends out there. It's not alone, and it has its own moon too, so it's totally fine. Chapter 2, Mars. Mars' size and diameter is 4,220 miles, or 6,780 kilometers. It has 2 moons. The distance from the Sun is 142 million miles, or 228 million kilometers. The time it takes to orbit the Sun, or 1 Martian year, is 687 Earth days. Planetary data. Like Mercury, Venus, and Earth, Mars is a terrestrial planet with a very rocky surface. Mars has been nicknamed the Red Planet because the minerals that make up its surface have a distinctive rusty color. Mars has two moons, Phobos and Deimos. Mars has a similar day length to Earth, with one rotation taking about 24 hours, but because it is farther away from the Sun, a year on Mars is almost double the length of a year on Earth. How big is Mars? Mars has a diameter of 4,220 miles, or 6,780 kilometers, while the Earth has a diameter of 7,928 miles, or 12,756 kilometers. That means Earth is almost 2 times the size of Mars. For a good example of the size difference between Earth and Mars, look outside your window at night. Earth's moon has a diameter of 2,159 miles, or 3,475 kilometers, meaning it's about half the size of Mars. So here's a size chart. There's the moon. Double that is Mars. Double that is Earth. How far away is Mars? Mars is 142 million miles, or 228 million kilometers away from the Sun, and 35.8 million miles, or 57.6 million kilometers from the Earth. For comparison, the distance between Earth and its moon is 238,855 miles, or 384,400 kilometers. That means Mars is almost 150 times further away from Earth than the moon is. That's a long trip. Fun fact, if there was a road through space, it would take your family about 74 years to drive from Earth to Mars without rest stops. So here's another diagram, the distance between Mars and Earth, and the distance between Mars and the Sun. Here's the moons. Here's Phobos. Phobos in diameter is 13.8 miles, or 22.2 kilometers. It orbits Mars, discovered in 1877, was named after the son of Ares in Greek mythology. Planetary data. Discovered by Asaph Hall, Phobos is mostly made of rock. This moon is slowly moving closer to Mars, about 6 feet or 1.8 meters every 100 years. At this rate, in about 50 million years, Phobos will either hit Mars or break apart to form a ring. And here's Deimos way over here. Deimos' size and diameter is 7.7 miles, or 12.5 kilometers. Orbits Mars, discovered in 1877, named for the son of Ares in Greek mythology. And planetary data. Deimos was the first Mars moon discovered by Asaph Hall. It is mostly made of rock. With the exception of a few recent craters, this moon is smooth due to rock and regolith deposits along the surface. It takes 30.3 hours for Deimos to orbit Mars. And fun fact, Deimos and Phobos were the twin sons of Ares, the Greek god of war, and counterpart to the Roman god Mars. Deimos means dread, while Phobos means fear. Here it says Phobos is the larger of the two moons, and Deimos is seen on the right. They said that already. That's okay. How big are Phobos and Deimos? Compared to Earth's moon, Mars's moons are tiny. Phobos is 156.5 times smaller than the Earth's moon, while Deimos is 280 times smaller. So here's a size chart. There's Deimos, there's Phobos, and here's our moon. These are so small. Mars's surface. Mars is a terrestrial planet, meaning it has a rocky, solid surface covered in minerals. Mars's soil is rich with iron minerals. As these minerals are exposed to the elements, they oxidize or rust, giving Mars's surface and atmosphere its red color. And, I hit my mic. Fun fact. Earth is about twice the size of Mars, but Mars and Earth have a similar amount of land area. Since about 2/3 of Earth's surface is covered in water, the remaining land covers roughly the same area as the surface of Mars. How interesting. Mars's geography. Mars has canyons, volcanoes, dry lake beds, and craters across its surface, much like Earth does. Windstorms and volcanic eruptions have left their mark on the face of Mars. The Valles Marineris is the largest canyon in our solar system. It is over 1,864 miles, or 3,000 kilometers long, and 4.9 miles, or 8 kilometers deep. That's close to 10 times the size of the Grand Canyon. And yeah, you can see it right here. Isn't that amazing? Mars has the solar system's largest, deepest canyon and the highest peak. I don't think this book talks about Mons Olympus, but like double the size of Everest, I think it is. The two sides of Mars. If you look at this map of the relief of Mars, you will notice that the terrains in the northern hemisphere are at a lower altitude and are much smoother than the terrains of the southern hemisphere. Most of the southern terrains are very old mountains and craters, while the northern terrains are relatively younger plains. The division between the highlands in the south and the lowlands in the north is called the dichotomy boundary. Scientists think that it was created either by the impact of one or several large asteroids, or by plate tectonic processes, similar to those that exist on Earth. Yeah, you can see here that, blue means low. You can see how much of the north is flat and how much of the south is rocky. And I think it says down here about this crater. And the dark blue area in the south of Mars is the huge Hellas Basin. It was created by an impact of a large asteroid. Landscapes of Mars. Many of the landscapes on Mars look very familiar to us. In particular, there are river channels, lake beds, and river deltas that look very much like those we see here on Earth. The presence of these landforms suggests that liquid water was flowing on the surface of Mars in the past. By comparing these landforms with those we find on Earth, it is possible to estimate how much water flowed at the surface of Mars and reconstruct the geological and climatic history of the red planet. So these two pictures here, let's see, this is Mars and this is a delta in Alaska. I bet you couldn't tell which one was on Earth and which one was on Mars, could you? Well, you could probably tell because that's a bunch of ocean water and rivers. But you could see the dry riverbeds here in this delta. And this says down here that a delta is a triangular-shaped landform created when materials like rocks, soil, and minerals carried by a river are deposited into an ocean or lake. Polar spiders, which is not as bad as it sounds. It sounds like a nightmare. Some of the landscapes on Mars are very strange and unlike anything we see on Earth. The South Polar region of Mars has especially unique landforms that scientists call areniform landforms, meaning landforms shaped like a spider. The spiders are networks of channels in the ground, which are covered in a layer of carbon dioxide ice. These spider-shaped landforms appear every spring at the South Pole and are formed by a process unique to Mars. See the little spiders here. It talks about them, I think, on the next page. Yeah. Polar spider formation. Polar spiders form when carbon dioxide ice located under the surface turns into gas as the temperature warms up in the spring. At first, the gas is trapped under the top layer of ice. When the pressure becomes too strong, the surface ice breaks, creating a hole through which the gas can escape. As the gas rushes to escape, it carves a spider-like network of channels on the surface. When the gas breaks through the surface, it erupts in the form of tall geysers of dust and gas, a bit like the geysers you can see in places like Yellowstone National Park in the U.S. The dust falls to the surface and forms long, dark streaks on top of the spider-shaped channels. So this is clearly a computer-generated image of what it would look like. Pretty crazy. And nothing like we have on Earth. Kind of. Mars's atmosphere. Unlike Earth, Mars has a very thin atmosphere made up of carbon dioxide. Not only does this mean that the planet cannot hold heat very well, but it also doesn't provide much of a barrier against asteroids, meteorites, and comets. Mars's sky appears hazy thanks to the dust suspended in the atmosphere. It says up here that the Martian sky is grayer than Earth because of the thin atmosphere. Mars's climate. The climate on Mars is influenced by the ice caps at its poles. As the surface warms up during its orbit, carbon dioxide and water vapor leave the planet and move into its atmosphere. During the spring and summer, dust storms appear all across Mars. Every 5.5 Earth years, which is 3 Mars years, a global dust storm will start, covering nearly the entire planet in suspended debris. These storms can last for weeks or even months. I guess these are photographs from 2001, before the storm, a regular day on Mars, and during the storm, where it's just a blob. You can barely see anything on it because it's covered in a dust storm. Can you imagine a storm that covers the entire planet? That would be so wild. Water on Mars today. Frozen water. Oh, sorry, I keep hitting my mic. I'm really close to it right now. A large amount of water was flowing on Mars in the past, so where did all of it go? Some of it escaped into the atmosphere, while the rest stayed on the planet, but it took different forms. Since the average temperature on Mars is negative 81 degrees Fahrenheit, or negative 63 degrees Celsius, almost all of the water found today at the surface of Mars is contained in its polar caps, which are made up of carbon dioxide ice and water ice. If all of the ice in the polar caps melted, it would cover the whole planet with a layer of water 65 to 130 feet, or 20 to 40 meters deep. Some of the water is also stored in the form of glaciers and ice patches inside of craters. So yeah, average temperature on Mars is negative 81 degrees Fahrenheit, or 63 degrees Celsius. Average temperature on Earth is 57 degrees Fahrenheit, or 14 degrees Celsius. And the freezing point of water is, of course, 32 degrees Fahrenheit, or 0 degrees Celsius. So that's why Mars is frozen ice. Earth, not so much. Not on most of it. Only the very cold parts. Groundwater. Some of the water went deeper into the ground. Water ice lies just beneath the surface across about a third of the planet. Mars's frozen ground is similar to the permafrost, or ground that remains frozen for 2 or more years, that we find on Earth in cold regions like Alaska or northern Canada. Between 30% and 99% of all the water that was on Mars in the past may be locked much deeper into the crust of the planet. So you can see a regular surface here down to about 1.5 meters, but then you start getting to this ice-rich layer of all the frozen groundwater. What's it say here? Water ice is stored in the ground beneath the surface of Mars, blah, blah, blah. I don't like how these little boxes sometimes just repeat what we just read. So I'm skipping a lot of them. Liquid water. Liquid water is unstable in the environmental conditions that exist on Mars today. Water would have to be extremely salty to stay liquid at the surface of Mars. Some scientists think that dark streaks on the slopes of some craters are formed by short-lived flows of salty liquid water. In 2018, another scientific study detected possible underground lakes located 1 mile, or 1.6 kilometers, beneath the surface of Mars. However, not all scientists are convinced, and more research is needed to find out if there really is liquid water on Mars today. You can see these streaks here, which could have been streaky water running down, right? We don't know. Chapter 3, Mars Through the Ages. Here's the history section. The Noachian, a time of warmth and water. The geological history of Mars is divided into 3 main periods: Noachian, Hesperian, and Amazonian. Mars today is a dry and cold desert, but its surface tells us the story of a time when it was much warmer and wetter. More than 3.7 billion years ago, during the Noachian epoch, bombardments by asteroids and volcanic activity were intense. Gas from volcanic eruptions caused the atmosphere to thicken, and the planet became warmer. rain fell to the surface, forming lakes and rivers, and maybe even an ocean. Scientists estimate that all of the water that existed on ancient Mars was equivalent to a global ocean about 2,000 feet or 600 meters deep, with 1/4 of the amount of water in the Atlantic Ocean. Some Martian environments were very similar to those on today's Earth. If those favorable conditions persisted for millions or billions of years, simple life forms may have even emerged. So here's what Mars would have looked like 3.7 billion years ago. Isn't that something? The Hesperian transition to a desert planet. The Hesperian was the period between 3.7 and 2.9 billion years ago. Asteroid impacts and volcanism decreased. The atmosphere of Mars progressively escaped to space, and the climate became colder and drier. If life existed, the harsh conditions would have caused its extinction. The water froze into the ground or escaped into space. Some of the frozen water was heated by asteroid impacts, and once it melted, it led to catastrophic floods. The volume of water in some of those floods was equivalent to several Mississippi rivers. I like how the stats are based on American geography, or U.S. geography. The resulting channels created by these floods, called outflow channels, are still visible on the surface of Mars today. You can see all these old flows. Pretty neat. The Amazonian, a desert planet. The Amazonian started 2.9 billion years ago and continues on today. During most of that period, Mars has been a dry and arid desert. Wind erosion has reshaped large parts of the planet and covered and eroded older terrains. Some dune fields created by the wind are still active today. Scientists use images taken at different spans of time to observe changes in the shape of the dunes and study their evolution. Mars may be dry and cold, but it is an active planet. You can see some of the dunes here. Isn't that beautiful? Looks like modern art. It's gorgeous. Mars's ice ages. Mars, like Earth, has experienced multiple ice ages over the course of its history. During these periods, the climate was extremely cold. Ice and glaciers covered a large portion of the planet, all the way to the equator. On Earth, most of the glaciers melted as the climate got warmer. But on Mars, many of them remained frozen and were covered by rocks and dust. Scientists are studying images of these glaciers to learn more about climate change on Mars over the last hundreds of millions of years. Here's what it looked like during the Ice Age, we think. The discovery of Mars. Here's a timeline. Circa 1500 BCE, Mars is named Har-Desher, meaning the red one, by Egyptian astronomers. 1045 BCE, Chinese astronomers accurately track the motions of Mars. Circa 400 BCE, Babylonian astronomers record sightings of Mars, including orbit estimation. Circa 360 BCE, Plato observes the relative distance of Mars compared to the other planets. Circa 110 to 170 CE, Ptolemy studies Mars's orbit compared to Venus's and Mercury's. Circa 500 CE, the Indian astronomical text Surya Siddhanta estimates the distance between Mars and Earth. 1609 CE, 1609, Galileo Galilei is the first person to observe Mars through a telescope. 1877, Asaph Hall discovers Mars's moons, Phobos and Deimos. And 2015, NASA discovers evidence of trace amounts of liquid water on the surface of Mars. Mars in the night sky. Mars is one of the 5 planets in our solar system that can be seen without a telescope. The other 4 are Mercury, Venus, Jupiter, and Saturn. Depending on the time of year and where you live, you may be able to see Mars in the sky at night. Mars stands out thanks to its reddish-orange color. It is also slightly bigger than most of the stars you see in the sky, making it easier to pick out. Fun fact. In the 1500s, after observing the stars, planets, and the moon in the night sky for 20 years, Danish astronomer Tycho Brahe figured out the position of Mars without a telescope, just using math. I took an astronomy class in college. It was literally Astronomy 101, and we learned about how to do that using the math developed by Tycho Brahe, and of course it's all completely gone from my mind now. But it was really neat that I could calculate the moon, where the moon was going to rise and set each day, where Mars and Venus were going to be each day. That was fun. I love astronomy. Chapter 4, Life on Mars. Throughout history, people have wondered if Mars was home to intelligent life. Around the 1800s, astronomers believed they had discovered canals on the surface of Mars and claimed that was proof of intelligent life. The canals were an optical illusion, but the idea of Martians stuck. Researchers have yet to find any concrete signs of life on the surface of Mars, but some scientists theorize that Mars may have supported some forms of life in its past. So you can see the canals here, which there's a little quiz in the back of this book. We're not going to do it, but I did it for my brother-in-law, and he was confused because he was like, can't you have canals without life? And I'm like, no, canals are man-made. And he's like, oh. Because, like, there's a difference between a canyon and a canal, right? A canal is meant for irrigation and such. There's no canals on Mars, although it does certainly look like it, doesn't it? The search for past life on Mars. Data from the Martian rovers tell us that some environments on Mars were habitable in the past. These habitable environments not only had liquid water, but also the geochemical components necessary for life to exist. If life did appear on Mars, it would be similar to early terrestrial life, primitive single-celled organisms like microbes and bacteria. Such organisms would likely have left evidence of their presence in the rocks, such as microfossils or remains of ancient microscopic organisms, or molecules created by biological processes. Scientists are searching for that evidence using the instruments on the Martian rovers. Finding evidence of past life on Mars, even if it was microscopic, would be an amazing discovery that would revolutionize our knowledge and perception of life. So when would we think this was? It says long ago. Okay. What Mars probably looked like, which looks like it would definitely have been home to some kind of little amoebas or little tardigans, whatever, little guys, right? Present life on Mars? Question mark. If life once existed on lowercase Mars, if life once existed on Mars, it would have become extinct at the surface when the climate changed and the conditions became colder and drier. However, some forms of life might have survived below the surface, possibly in underground pockets of warm, salty water or deep inside caves. Underground, life would be protected from the harmful solar radiations that make the surface uninhabitable. Some living organisms on Earth have been found in extreme environments, miles under the surface, without light or oxygen. Similar organisms might still live on Mars today, although scientists have not found any evidence of their existence at this time. That's true, we have like tube worms at the bottom of the ocean, and what is it, that cave, I think it's in Croatia, or in the Czech Republic, somewhere around there. I'm getting a C, I'm getting psychic readings, I think it starts with a C. There's a cave, I want to say Croatia, where this blind worm lives, that only lives in the dark, and only lives in that one cave. Like something like that could exist on Mars for all we know. Isn't that neat? It's a little rover attempting to go into a cave. Maybe someday, not yet anyway. It says Mars on Earth. You can experience a bit of Mars here on Earth. Some places on our planet are so similar to Mars that scientists are studying them to better understand the Martian environment. Those places are called terrestrial analog environments. Some analogs are similar to Mars today, while others resemble Mars in the past. Some of these sites are also used by scientists to simulate the living conditions that will be encountered by astronauts on future missions to Mars, so they can better prepare the astronauts for the journey. Such sites exist in many different locations on Earth, such as Meteor Crater in the US, the Atacama Desert in Chile, or the islands of Svalbard in Norway. So this is Lake Salda in Turkey, and apparently it closely resembles the Jezero crater on Mars. At least the rocky white shoreline there resembles the crater. Chapter 5, Exploration of Mars. Even before the Apollo 11 mission put a man on the moon, scientists were working out how to get a closer look at our neighboring planet. While astronomers have been fascinated by Mars throughout history, it wasn't until recently that scientists even saw the surface of Mars in detail for the first time. Before the Mariner 4 flyby in 1965, studies of the red planet were done through the high-powered telescopes that can only work out rough details. So this is a photograph taken in 1965. That was all we knew of the surface of Mars. Hopefully you didn't hear that loud truck go by. I just realized that it's garbage day. At least that's what we call it in the US, where the garbage trucks come. Uh-oh. I gotta wrap this up. They're probably not going to come for a couple hours, but I can't be filming when there's garbage trucks outside. Whoopsie. Here's Mariner 4. Its mission was to conduct a flyby of Mars and take photographs. It launched in 1965. Planetary data. The Mariner 4 was one of a series of 10 spacecraft sent to record information from Mercury, Venus, and Mars. The Mariner 4 provided NASA with the first up-close pictures of Mars and paved the way for future Mariner missions. Here's Viking 1 and 2. I assume they looked the same. Their mission was to land a spacecraft on the surface of Mars. It was launched in 1976. Planetary data. The Viking 1 and 2 orbiter and lander spacecraft became the first to land on the surface of Mars. Viking 1 landed first on July 20th, 1976, followed by the Viking 2 on September 3rd, 1976. Both spacecraft conducted biological experiments to try and detect signs of life on Mars. While they did not find any signs of life, they did find valuable information about the surface of Mars. Mars orbiter since 1996. Why are there so many loud trucks outside? I hope that's not the garbage truck. Imagine. Oh my gosh, imagine. Okay, I don't think you guys can hear, but it's pretty loud. Oh my gosh, I think it is the garbage truck. We gotta wrap this up. In 1996, NASA launched Mars Global Surveyor, the first successful U.S. mission to Mars since the Viking missions in 1976. Since then, many spacecraft have been sent by the U.S., Europe, and other countries to orbit Mars. They have provided us with an enormous amount of data that has revolutionized our knowledge of the red planet. These missions sent back in-depth information on the topography, atmosphere, geology, mineralogy, water content, and internal structure of Mars. They have allowed scientists to produce detailed maps of Mars, create 3D models of its relief, and even see under its surface. Images from the HiRISE camera on the Mars Reconnaissance Orbiter, launched in 2003, show us details as small as a coffee table on the Martian surface, and can even produce 3D models of these features. And here's the Mars Reconnaissance Orbiter. Here's the Mars Pathfinder. Its mission was to land the first robotic rover on Mars. It was launched in 1996. Planetary data. The Mars Pathfinder only explored Mars for a few months, but it accomplished its mission of being the first rover to land on the planet. This paved the way for future exploration efforts, like the Mars rovers. The Pathfinder had onboard equipment to study both the atmosphere and soil of the planet. The spacecraft had an innovative way of landing on the planet using technology that included a parachute and huge airbags. And here's Spirit and Opportunity. Their mission was the exploration of Mars. They were launched in 2003. Planetary data. The Spirit and Opportunity rovers were launched to explore the surface of Mars to determine whether or not the planet ever had water on it. The mission was a success. The rovers found evidence of liquid water. Both rovers have mounted cameras and a robotic arm that works much like a human arm. These features have allowed the rovers to take panoramic images of the planet, as well as samples of the planet's surface. Here's the Phoenix Mars lander. Its mission was to study water ice and habitability in the Martian Arctic. It was launched in 2007. Planetary data. The Phoenix mission was launched to search for evidence that water ice just below the surface was once liquid. Equipped with cameras that could identify minerals and geographical locations, the Phoenix Mars lander studied the soil on Mars to determine if there were conditions that could support life. The mission ended in 2008 after the Phoenix provided scientists with detailed readings on the surface and atmosphere of Mars. Those big old solar panels. Here's Curiosity. Curiosity's mission is the habitability of Mars, and it's launched in 2012. And what's great is that this is like a rendering of what Phoenix would look like on Mars. This is an actual photograph of Curiosity on Mars taking a selfie of itself. Isn't that so cool? This is not a rendering, this is an actual photograph. Curiosity was launched in 2012. Planetary data. The Curiosity rover landed on Mars on August 6, 2012 to analyze rock and dirt samples and evaluate whether the environment was capable of supporting microbial life. Outfitted with a solar power supply and the ability to travel an average of 98 feet or 30 meters per hour, Curiosity has since traveled over 6 miles or 10 kilometers and is still functioning. Curiosity drills rocks, analyzes samples, and has even taken a Mars selfie. Fun fact, every year on August 5th, the Curiosity rover sings itself happy birthday to commemorate its landing on the surface of the planet. I wonder if it's the 5th or 6th. It's two conflicting dates, but it does sing itself happy birthday alone on Mars. Here's the InSight lander. This looks like a rendering, or at least this part. Its mission is to explore Mars's deep interior. It was launched in 2018. Planetary data. InSight has placed a seismometer on the surface of Mars to measure seismic activity for Marsquakes. I love that. And provide information on Mars's interior structure. InSight's seismometer has been detecting new Marsquakes every day and has allowed researchers to create the first ever map of the interior of another planet. It revealed that the crust of Mars, or its topmost layer, is between 12 and 23 miles, or 20 to 37 kilometers thick, and the underlying mantle extends 970 miles, or 1,561 kilometers, down to the core of the planet. The core of Mars is also bigger, 1,137 miles, or 1,830 kilometers in radius, and has more liquid than scientists expected. Learning about the interior structure of Mars could bring a new understanding of the formation and evolution of terrestrial planets. And here's Perseverance, and this is a selfie. This is an actual photograph of Perseverance on Mars. You can see the camera there. Saying hello. Perseverance's mission is to search for evidence of ancient life at the surface of Mars and collect rock and soil samples to be returned to Earth in the future. It was launched in 2020. Planetary data. The Perseverance rover landed on Mars on February 18, 2021 in Jezero crater. This landing site was chosen because images from orbit show that it contains an ancient river delta. A very long time ago, Jezero crater probably contained a lake. The sediments that are deposited in river deltas and lakes are known to preserve signs of life over long periods of time. Therefore, Perseverance's landing site is a very good place to look for signs of ancient microbial life on Mars. To accomplish its mission, the rover will use its many instruments to analyze the rocks and the surrounding atmosphere. Is that its little buddy, its little drone there? I think so. Oh yeah, here it is. The Ingenuity helicopter. Perseverance did not land alone on Mars. It carried on its belly a small helicopter called Ingenuity. The first objective of Ingenuity was to demonstrate that it is possible to fly a remote-controlled aircraft on Mars. Such a flight had never been attempted before. On April 19, 2021, Ingenuity made history by completing its first flight on the red planet, taking off vertically, hovering 9.8 feet or 3 meters above the surface, and landing after 39 seconds. Well, it's like the Wright brothers on another planet, right? Wow. Since then, it has completed several other flights, higher and longer than the first one. These flights are used to test how such an aircraft can help us better explore Mars and other planets in the future. Chapter 6, Future Missions. NASA and other space agencies are always working on sending new probes and spacecraft to Mars to help discover more about the surface of the red planet and to help prepare for a manned Mars mission. The launch of the Perseverance rover is the first phase of an ambitious mission to return samples of the Martian ground to Earth. Future Sample Return Mission. The rovers are able to perform very advanced analyses of the Martian rocks. However, some types of studies can only be performed by scientists on Earth. For that reason, NASA is planning to bring back some of the Martian rocks to Earth. Whenever the Perseverance rover finds particularly interesting rocks or sediments, it stores a sample in a little tube and leaves the tube at the surface of Mars. In 2026, another rover will retrieve the samples, and a rocket will launch them into the orbit of Mars. In 2028, a new spacecraft will recover the samples in orbit, and then return to Earth in 2031. The samples will then be analyzed directly by scientists in laboratories on Earth. Those analyses will hopefully lead to new and exciting discoveries about Mars. So by 2031 at the earliest, we'll have actual Mars samples on Earth. That's crazy to think about. The first time we have a piece of another world on our world. That's wild. It's hard to wrap my head around. Besides like the moon. The moon is ours. It doesn't really count. Human exploration of Mars. In addition to robotic missions, NASA plans to send human explorers to Mars. Human missions to space pose many challenges, and new technologies have to be developed and tested to ensure the health and safety of the astronauts. Because of the very long distance between Mars and Earth, astronauts on a mission to Mars would be away from Earth for at least 2 years. Before we send humans to Mars, we need to make sure that they will have all of the necessary technology to live far from Earth for such a long time. For that reason, we will probably not see a human set foot on Mars before the 2030s. Who knows? The first astronaut on Mars may be you. Wow. A little rendering here of what Mars spacesuits look like. They probably shouldn't be rust-colored because then they're going to blend in, but maybe they won't. There's a little true or false quiz, but we're going to end our video here for tonight. So thank you so much for watching. Wasn't this book cool? I guarantee you learned something. Let me know what you learned down in the comments below. I hope you found this video to be relaxing and educational, and I hope that you have a good night. Good night.